Assalamu alaikum. Chapter 12, section 1, talking about solution. First, we want to distinguish between the type of mixtures. The mixture is the substance that consists of more than one substances mixed together in any proportion. And for example, when I say NaCl, means that each molecule of NaCl consists of one atom of sodium and one atom of chlorine, and this proportion should be constant. But when I say salt solution, you can add any quantity of salt to any quantity of water. So this means that solution is a type of mixture. Mixtures are divided into two types: homogeneous mixture, where the composition is uniform throughout, and heterogeneous mixture, where the composition is not constant throughout. This is one way to classify mixture. Another way to classify the type of mixtures into solution, suspension, and colloid. Suspension. Okay, let us start talking about each one of solution. As you know, it is a homogeneous mixture that consists of solute, the substance that dissolve, and solvent, the substance in which the solute dissolve. Many of us think that solution should be something dissolved in liquid. Many of us think that solvent should be liquid. Actually, no. Solvent can be solid, can be liquid, can be gas, even solute can be solid, can be liquid, can be gas. So for example, when you say oxygen in nitrogen, oxygen and nitrogen both are gases. So oxygen is the solute, and nitrogen is the solvent. Why? Because nitrogen in air is found in the greater quantity, so the substance that is found in a greater quantity, we call it solvent, and the substance that's found in a smaller quantity, we call it solvent. Okay, something like carbon dioxide in water. So here carbon dioxide is a gas, and water is liquid. So it can be gas in gas, it can be gas in liquid. When I say alcohol in water, alcohol dissolve in water, so this is liquid in liquid. When I say mercury in silver, in what we call it amalgam, like that used by the dentist to fill the tooth, in silver, this is an example for liquid in solid solution. Also sugar in water, this is solid and liquid. And the alloy like copper and nickel, copper and nickel alloy, sabika, so this is solid and solid. So as you see, solution can be gas in gas, can be gas in liquid, can be liquid in liquid, can be liquid in solid, can be solid in liquid, and can be solid in solid. Okay, this is for the solution. The second type of mixture is the colloid. Colloid, the famous example for colloid is the milk, for example. Milk is mainly water and the protein. The molecule, if the protein is not too small to dissolve in water and it is not too big to precipitate, so the molecule of protein is still suspended in the colloid. So also we have types of colloid, can be like the gel, it's solid protein in water. The protein gelatin make like a network, jelly-like. So this is a kind of colloid, like foam. It's like the shaving cream or the whipped cream. It is gas dispensed or suspended in liquid. So they make the foam like this. So this is the colloid. It is a substance that is not soluble in the solvent. And then the suspension like a chalk in water, clay in water, the substance size is too big such that they cannot be carried by the water molecule, they can't suspend and they don't dissolve, so by standing they settle down. Clay in water. This is an example. So let us make a table of comparison between suspension, colloid, and solution. This is the solution. Okay, SOLN solution. This is the colloid, and this is the suspension. Okay, so if you talk about the particle size, solution will be small, such that they can dissolve. In colloid, they are medium size. You don't need to memorize the number, and suspension, they are big, compared to colloid and solution. This is first point of comparison. Second point, how can we separate the particles and the solvent? In solution, by standing, if you have salt solution, by standing the sodium chloride, the salt or the sugar dissolved, do not precipitate by standing. Can't separate by standing. Okay. In colloid also can't. If you leave a cup of milk, the protein will not separate from the water. But here in suspension, it can. If you have a chalk, you irrigate it or you stir it vigorously and then you leave it, the chalk particles will settle down. Okay, another point of comparison, can you separate the components of this mixture by filtration? In solution, can't. If you pass salt solution through a filter paper, all the solution will pass, including the solute and the solvent. Can't separate. By standing, by filtration, sorry. By filtration. Here also can't. Okay, the milk, all the milk will go through the filter paper, including the water and protein, while in suspension, it can. So if you have a chalk with water and you pass it through filter paper, the chalk will filter out and the water only will pass. So as you see, it is difficult to differentiate between the colloid and the solution because both of them cannot be separated by standing, both of them cannot be separated by filtration. So what is the way you can differentiate between colloid and solution is the Tyndall effect. You pass a beam of light through them. If the light penetrates, this is solution, and if the light doesn't penetrate or is scattered, this is colloid. Because in the colloid, the particles do not dissolve, so they scatter light. This is called Tyndall effect, whether the light will scatter or not. For sure for suspension, because the particles are not soluble, so they also scatter light. So here I will write penetrate light. Here scatter light. And here also scatters it. Okay, so from this comparison, you can use it to differentiate if the mixture you have is a solution or colloid or suspension. The last thing here is the, after the Tyndall effect, is to differentiate between the term electrolyte and the non-electrolyte. So what is electrolyte? For sure, when I say electro means something related to electricity. Electrolyte, this is the substance that can dissociate into ions. The solution gives ions. And when the solution gives ion, then this means that the solution will conduct electricity, because you know that electric current is the flow of charge. So for example, when I say sodium chloride in water, it will dissociate into Na plus and Cl minus, right? So if the solution contains Na plus and Cl minus, these ions, you can complete the electric circuit. Okay, if you have a lamp here, for example, the lamp will lit because the circle is complete. You have ions passing in the solution, and it can complete the electric circuit, and it conducts electricity. So this is called electrolyte. Non-electrolyte is the substance that its solution does not conduct electricity because it doesn't give ions. So non-electrolyte. Okay, like sugar solution, if you put sugar in water, the sugar will not dissociate into ions. So they will stay sugar particles in water, sugar solution. The sugar stays sugar, so it doesn't dissociate into ions, it doesn't conduct electricity. So if you have here sugar solution, and this is the electric circuit, this is the lamp, and this is the battery, like this. So here the sugar does not make any ions to complete the circuit with the wires or electrodes. So this is why it doesn't conduct electricity, and the lamp will not lit. So sugar is a non-electrolyte. And this is all for this section.